This is a solution for case J. If you have not attempted to solve case J on your own, then please stop this video and attempt to solve the problem before returning to the video to see this solution. Assuming that you have attempted to solve this one on your own now, hopefully you'll see that case J is really one of the easiest cases that we've considered so far. We're going to need a Venn diagram because we're given some pretty simple events. The probability of A erupting is equal to 0.1. The probability that B erupts is equal to 0.1. But we were told that the probability of any one going off, given that the other one has gone off, is equal to 0.6. And that's not uncommon in terms of, given volcanic activity happening because magma's active or reanimated in one volcano, probably an adjacent volcano is fed off the same magma. So those two events probably are going to be more likely to be occur simultaneously. Once one's gone off, the other one might go off. So what does that mean, though? By definition, that means the probability of A and B divided by the probability of B. And what we don't know is how much we have in the intersection, but we do know that probability of B is equal to 0.1. So we're being able to figure out now that the probability of the intersection is equal to 0.6 times 0.1, or 0.06. So when we draw our circles, we know that A has a probability of 0.1 and B has a probability of 0.1, but they have a huge overlap. So A is here and B is here, and we know the interior, the being inside both, is 0.06, but the portion of B that lies outside the intersection is 0.1 minus 0.06, or 0.04, and the probability in A only is 0.04. So we can get right to answering this question. What is the chance that the city will experience volcanic activity during the next 50 years? This is really just asking what's the probability of A union B, which is equal to the sum of those three events, those three separate portions, 0.04 plus 0.06 plus 0.04, which is 0.14. But there's another way that we could calculate that. The probability of A union B is equal to the probability of A plus the probability of B minus, because we don't want to double count it, the probability of A and B going off. So that's 0.1 plus 0.1 minus 0.06. So that's 0.2 minus 0.06, which is equal to 0.14, which is the same answer that we got by calculating the three separate events that we just summed. I like the first version because notice the way I had those probabilities written here in the Venn diagram is I wrote each of those probability amounts out regarding them as mutually exclusive events. So I only calculated the probabilities of portions that didn't overlap, and then I could just sum them. So that was my preferred way of solving this problem. But the other one's perfectly fine. You're going to get full credit if you solve this problem either way. And that's the solution to case J.